Speaking of masterless, why don't we use that as the very first concept conversation? But before we move on forward, right, I want to ask a few commonsensical questions, right? Nothing to do with computer science. If you really see, CS stands for computer science, Counter Strike. It also stands for common sense. So what we're going to do is, let's look at this question which is there in front of you from a common sense perspective. Why do very large malls have more than one entrance? Why is that so important? If you really see, imagine there's a gigantic mall and you have a door which is probably about, maybe 5 feet by 10 feet wide. That door is going to be a single choke point. That door is going to act as a single choke point, not just in case of normal business operations, but in case of emergencies. Unfortunately, if something were to go wrong in that particular mall, you're going to find yourself in a situation where there is a stampede. That's never good. So wouldn't it be nice if the mall had multiple entry and exit points? So if one of the door collapses for whatever reason, there are other doors from where emergency help can go in as well as people can go out. If that is common sense, then the picture in front of you will make perfect sense. Now imagine all of the nodes in Cassandra are like gateway in and out. They are doors to your data in and out. What you see in front of you is what is called as Cassandra ring. A point of clarification here. The picture does not try to depict that node 1 is able to communicate with node 12 and node 2 only. No, that's not what it's depicting. The ring that you see here, this is the network on which all of these nodes reside, which means every node can talk to every other node, a fundamental need of a peer-to-peer system, a masterless system. This is just a representation. And to the left of this diagram, we have clients. There can be n number of clients communicating with Cassandra. Take a look at this picture. And what is it trying to tell you? It's basically saying that client 1 is communicating with node number 12. Client 2, same thing. Client 3, yet another node. Now you might be wondering, okay, wait a minute. We've been talking about masterless architecture and peer-to-peer system, but this is a classic case of master-slave architecture. Client 1 is communicating with node 12. What happens if node 12 goes down? Doesn't that cause client 1 to sit around without any underlying data store to communicate with? Well, this picture indeed tends to depict that picture, isn't it? But you know what? Think of this particular picture as a snapshot or a point in time truth. What I mean by that is, if I roll time, just like, in the early days, there used to be films, right, which used to go through the movie projector. You move the film at a specific speed, and that's where you get the moving picture on the screen. You remember the good old times? Imagine this is one such frame. Just think that if I were to go to the next frame, you might find client 1 communicating with node number 1. Move next frame, client 1 is communicating to node number 2. Next frame, 3. Next, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, go back 1, 2, 3, 4. If I were to move this film, you will basically see these two lines start moving in a clockwise fashion. This is the default algorithm that a Cassandra client uses, round robin. In other words, think of it like this. This is an application which intends to select some data. So it might ask node 12, hey, here's a select, go do your thing. Next, it might want to insert some data, but it probably will not ask node number 12. It just operated on it. It's going to move on to the next one and say, hey, you're going to do the insert. Select, insert, update, insert, 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 select, 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 update, insert, delete, select, select, select. You see what I'm saying? So the client will have the ability to bounce the connections and use these different nodes in a round robin fashion. What does this give? What is the benefit this brings on the table? At any point in time, the client is not overloading a single node, number one. Number two, it has connections to all of these nodes in the ring, essentially the Cassandra cluster, and therefore has the ability to tolerate a node down. So if, let's say, node 1 was down, and if the client knew about that, and there are ways to know that, gossip I will talk about in a little bit. So the client can say, okay, node 12, oh wait, node 1 is down. Okay, next to your node 2. So 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like this, it's constantly round robin around the Cassandra ring. Isn't that awesome? So this way, what happens is Cassandra individual nodes do not get overloaded, and you're able to evenly distribute not just the data, but also the workload necessary to retrieve and save the data in the cluster. I gave the example with just client 1. You can imagine the same thing is happening with client 2. The same thing is happening with client number 3. I'm sure you are probably thinking now, okay, wait a minute. How did client 1 know the existence of all of these nodes? How did that happen? What kind of setting is that? Do I have to specify all of the IP addresses of these nodes as a developer or an administrator in my application properties file? Well, that's going to be terrible. Imagine if my cluster size is 2500 nodes. So I have to specify 2500 IP addresses. That's not a good model at all by any stretch of the imagination. You're absolutely right if you're thinking like that. So there's got to be some mechanism by which the client is able to quote unquote auto discover the entire cluster. It would be really great if the client at the time of initialization, application initialization, if it can contact one node and ask a basic question. Hey, node 12, I know for a fact your Cassandra, your peer-to-peer system. That means one of the rules of peer-to-peer system is all the nodes know about each other. They know everything about each other. So node 12, would you be so kind as to let me know the IP addresses of all your peers? Wouldn't that be nice? It's not nice. That's exactly what happens. So client 1 can initialize with just one IP address. Of course, it can take a list, and I'll talk about the need for specifying a list a little bit later. But for now, just imagine if you provided node 12 IP addresses, node 12 IP address. Client 1 can ask node 12, listen, let me know the IP addresses of all your peers. And that's how client 1 is fully aware of all the IP addresses present in the cluster. So therefore, a question that begs the answer, how did node 12 know about all the IP addresses? How does each of the nodes in the ring know the presence of the other nodes? We're going to soon talk about a process called bootstrap. But the point of this particular topic is masterless. You now do realize that when an application initializes, the Cassandra driver, when it initializes along with that application, it knows about all the IP addresses of the nodes in the cluster, and therefore has the ability to contact any node. And the default algorithm is round robin.